All right. So in case a root is repeated k times, right? This is the solution. Actually, the solutions are like this. Y1 is e to the power rt, y2 is t times e to the power rt, up to kth solution, which is t to the power k times k minus 1 times e to the power rt. Okay. Let's see some examples. Let's, for example, find the general solution of, let's say, okay, so third derivative of y minus okay, 3 times, all right, let me write this way. Okay, well, we write down the characteristic equation, which is just r cubed plus 3r squared plus 3r plus 1 equals 0. And of course, this is nothing but r plus 1 to the power 3 equals 0. So r1, r2, and r3 are all equal to minus 1. And the solutions, of course, we obtain are then y1 is just e to the power rt, which is e to the power minus t. Y2 is just t times this, and y3 is just t times this, which is t squared e to the power minus t. So these are the solutions. Hence, the general solution is what? Y equals okay, c1, or maybe e to the power minus t parentheses. I have c1 plus c2 times t plus c3 times t squared. Okay, so c1 times this, c2 times this, c3 times this one. All right, so this is the general solution. Ci's are real or complex numbers. Okay. I said examples, but let me just do one example. We will do several examples later anyway. All right. Now, what about non-homogeneous equations? So, constant coefficient homogeneous equations are solved this way. You write down the characteristic equation, you look at the roots, whether they are repeated or not, you write down the solutions corresponding to the roots, and then you take their linear combination. So next topic will be just non-homogeneous linear constant coefficient equations. Constant olması şart değil. Linear equations, ordinary differential equations. We will see three methods. We will consider three three different methods. methods. One of them is reduction of order. So let's start with okay. Şuraya yazayım olmasa. Three methods. Reduction of order. The method of undetermined coefficients. And variation of parameters. We have already seen actually variation of parameters. So it will be just that method applied to this setting. The other two, reduction of order and undetermined coefficients, these are some new methods. Let me start with reduction of order, which is the second part of this section actually, 3.5, reduction of order. Again, maybe before I start this method, let me just consider, non-homogeneous equation. Consider a non consider the general form of an nth order linear ordinary differential equation, not necessarily homogeneous. So what is this? Well, it will be something like this. Let's say a nth derivative. Let me write this kind of notation: a n minus 1 and minus first derivative, and up to a1 y prime, a0 y, and I have gt. Okay, how can we solve something like this? I will introduce a notation. So let L y be the following gadget. Ya da şöyle diyeyim. Okay. Ly denote the linear term. Ly şu olsun. An and derivative up to a1 first derivative plus a0 times y. Okay. Then the equation is what? Ly equals gt. Okay. As usual, I mean, as in the case of systems, this equation, the general solution of the corresponding homogeneous equation Ly equals 0. So I just let gt to be 0 is called the complementary solution. Which is denoted which will be denoted as YC, a solution of Ly equals GT is called a particular solution of Ly equals GT, denoted as, again, YP. Moreover, as in the case of systems, the general solution of Ly equals GT will have the form yine şöyle olacak: G equals YC plus YP. Why is that? Because if you have two particular solutions or just two solutions, their difference is just a solution of the homogeneous equation. So the same idea, instead of systems, just consider this ordinary differential equation works here, and we see that the general solution is nothing but the general solution of the corresponding homogeneous equation plus a particular solution, just a solution. Let me explain this on an example. Consider the differential equation let's say this one, y double prime plus y equals t. Okay, so this is a non-homogeneous equation. Find its general solution. So how do we do this? Again, the general solution is complementary solution plus a particular solution, and complementary solution is nothing but the general solution of the corresponding homogeneous equation. So I just let this GT term to be 0 and solve this. How do we solve this? We write down its characteristic equation, which is just r squared plus 1 equals 0. From this we see that r is plus minus I. So what are the solutions for this then? So YC is just C1 times cosine t plus C2 times sine t, right? There's no real part, so there's no e to the power lambda t term. Mu is just plus 1, so I have sine t and cosine t. And here C1, C2 are just real or complex numbers. What about a particular solution? Well, in general, finding a particular solution might be challenging. We will see examples. But, I picked it up, this equation, so that it is readily seen, one of its solutions is seen easily. What's that? Well, just let yp to be t, right? Then when you plug it here, second derivative of this is 0. So y equals t is a particular solution of this, right? Since yp second derivative is 0, we see that We see that yp equals t is a particular solution. Hence, the general solution of the equation is what? Y g, which is yc plus yp, which is just c1 times cosine t plus c2 times sine t plus t. If I wanted to solve an initial value problem, then I would use the initial conditions to figure out this coefficients. Let me also continue this example and solve an initial value problem. Let's find the unique solution of the initial value problem. Let's see this. So y double prime plus y equals t, and I need two initial conditions. Let's say at 0 equals 0, and this is also 0. So trivial initial conditions. We have already obtained the general solution, so I will just use these conditions to write down two equations for the coefficients C1 and C2. Now, y0 equals 0 implies what? When you plug 0 for t, you get C1 plus, okay, C1 times 1, C2 times 0 equals 0 because t is 0. So from this we get C1 is just 0. What about y prime 0 is equal to 0? Well, y prime t is just minus C1 sine t plus C2 cosine t plus, okay, here I have this 0 plus 1 in this case, because when you take derivative you have 1, and that is 0. So when you plug 0 you get minus C1 times 0 plus C2 times 1 plus 1 equals 0. So from this we get C2 is just minus 1. Hence, yt, which is just C1 was 0, C2 is minus 1, minus sine t plus t is the unique solution. Okay, of the initial value problem. Okay, that's it. All right, so that's the general theory. To find the general solution of a non-homogeneous equation, we need to solve the homogeneous equation and obtain the complementary solution, and we have to find a particular solution. How do you find a particular solution? Well, we have seen, we will see three methods for that. As I said, reduction of order, undetermined coefficients, and variation of parameters. Let's start with the reduction of order. Okay, reduction of order. Okay, what is this? Okay, so the idea is this. Consider a second order. It doesn't have to be second order, but let's just consider now second order. Second order linear non-homogeneous equation. Let's say uh, L y equals gt, where Ly is this y double prime plus pty prime plus qty. So it doesn't have to be constant coefficient. Okay, so our equation is this: second derivative plus pty prime plus qty equals gt. Assume that uh, y, okay, buna bir isim verelim. Okay, y1t is a solution of the homogeneous of the associated or corresponding homogeneous equation. What's that equation? This one. Ly equals 0. In other words, or this one. Okay. All right. Well, what we will do is the following. To obtain a solution of the non-homogeneous equation, we try functions of the form y equals some function v times y1. Actually, this is kind of the variation of parameter method, right? There we had this fundamental matrix. Instead of C, I would have, we replace the C by an arbitrary function, vector valued function, and we tried this kind of gadgets to solve the equation. So we do something, similar. So idea is not actually, something very original, almost the same idea. And so where, of course, here v to be determined. So this function needs to be computed to be determined. All right. Well, we want from this equation to solve this gadget, right? Let me write just like this. And what we know is that y1 is a solution of the homogeneous equation. So it solves this equation. So when I plug y1 here, we get 0. Okay, so okay, so we have y equals v times y1. Let's start taking derivatives. What is y prime? They are both functions of t, so its derivative will be just v prime y1 plus v times y1 prime. And what about the second derivative? Well, that will be, okay, let me write here. Second derivative will be just v double prime y1 plus v prime y1 prime plus, and then I have terms coming from this gadget, v prime plus y1 prime plus v times y1 double prime. So what is this? This is v prime y1 plus 2v prime y1 prime plus v times y1 double prime. Let's plug all this into the equation. Plug them into the equation. So y double prime v prime y1 plus 2v prime y1 prime plus v times y1 double prime plus p times y prime, which is v prime y1 plus v times y1 prime plus q times y. Well, y is just v times y1 equals gt. Okay, so from this we get what? Let me collect y1 terms on one. Okay, so yeah, I have v double prime y1, and then I have v prime terms. V prime terms, what are they? V prime 2 y1 prime plus p times y1. Yes, and then I have v terms. What are the v terms? Y1 double prime plus p times y1 prime plus q times y1 equals gt. Well, you see, this is nothing but uh, 0. Why is that? Because y1 is a solution of the corresponding homogeneous equation. So this is by assumption. So this means there is no v term in this equation. So we get this v double prime y1 plus v prime 2y1 prime plus p times y1 v equals gt. Well, what kind of equation is this? This is again a second degree equation in v, right? However, no, I don't have v here, sorry. However, you see there is no v term, right? V term, the coefficient of v is just 0 by assumption, because y1 is a solution of the corresponding homogeneous equation, so this is 0. So although this equation, is a second order equation actually in v, since there is no zeroth derivative, I may consider this as a first order. How? So let u to be v prime. Then u prime is just v double prime, so that the above equation can be written as how? V double prime is just u prime times y1 plus u times 2y1 plus py1 equals gt, and this is just a first order ordinary differential equation in u. And since it is first order, we may solve this, right? This is a linear first order equation, and we know how to solve this. Of course, if the coefficient terms are, terrible, then we may have run into trouble, but there is at least hope for that. So let's see some examples. Okay, I'll do some examples. Okay. Find the general solution of what? Y double prime minus 3y prime plus 4y equals 3 times e to the power 2t. Well, how can we solve this? Well, Ly equals what? Y double prime minus 3y prime plus 4y, and gt is just 3 times e to the power 2t, right? The general solution has two parts, complementary plus particular. What is the complementary solution? Well, that is the equation solution of the homogeneous equation. So it is just y double prime minus 3y prime plus 4y equals 0. Well, this is easy to solve because it's a constant coefficient ordinary differential equation, which is homogeneous. You just write down its characteristic equation, which is r squared minus 3r plus 4 equals 0. And from this we get r minus, plus 1, r minus 4 equals 0. So r1 is minus 1 and r2 is 4. These are the solutions, roots of the characteristic equation. We have solution corresponding to this one, r1t, which is e to the power minus t, and solution for this, e to the power r2t, so it is e to the power 4t. So what is the general solution? General solution is the complementary solution, so it is e to the power minus t plus c2 times e to the power 4t. c1 and c2 are real or complex numbers. Özür dilerim. Evet, evet. Evet, şurası eksi olacak. Okay. Alright. Yes. Şimdi tamam değil mi? Okay. What about particular solution? Well, I will use reduction of order method. To apply the reduction of order method, I need one solution of the homogeneous equation. Well, I have many solutions of the homogeneous equation. So to use the reduction of order method, reduction of order method, let y1 to be just e to the power minus t, a solution of the homogeneous equation. So then let y to be just v times y1. So it is just e to the power minus t times v. And then we take its derivatives. Sorry, derivatives. What is, so y is just e to the power t times v. What is y prime? It is minus e to the power t times v plus e to the power minus t times v prime. And the second derivative, so I take derivative of this term, e to the power t minus t v plus, okay, minus e to the power minus t v prime, and then derivative of this, the same thing. So I have 2 times this plus e to the power minus t v double prime. And we plug all these into the equation. So it was, so plug them into what? Y double prime minus 3y prime minus 4y equals 3 times e to the power 2t. So let's see what we get. E to the power minus t v e to the power 2 times e to the power minus t v prime plus e to the power minus t v double prime minus 3 times y prime. Y prime is minus e to the power minus t v plus e to the power minus t v prime minus 4 times y, which is e to the power minus t times v equals 3 times e to the power 2t. E to the power minus t times v prime, and then I have v prime terms. What are they? Okay, v prime coefficient is minus 2 times e to the power minus t, and here I have minus 3 times e to the power minus t. Yes, and then we have v terms. So v terms, okay, coefficients are e to the power minus t, and then plus e to the power minus t minus 4 times e to the power minus t equals 3 times e to the power 2t. And this is the checkpoint, right? We need to have this thing to be 0, and it is 0. So our equation is then what? E to the power minus t v double prime plus v prime minus 2 times e to the power minus t minus 3 times, no, so this is just, okay, minus 5 times e to the power minus t v prime equals 3 times e to the power 2t. Actually, I can just take e to the power minus t to the other side, and we get what? Right? Multiply the equation through by e to the power t, we get this. And as we said, although this looks like a second order equation, actually it is first order in v prime. So let u to be v prime, then u prime is v double prime, So the equation hence get what? U prime minus 5u equals 3 times e to the power 3t. Well, this is a first order linear equation, right? First order first order linear ordinary differential equation. How can we solve this? We need to find an integrating factor, mu t e to the power pt dt, integrating factor. P is just minus 5, so it is just minus 5 dt, so e to the power minus 5t. So this is an integrating factor. All right, so multiply with this, e to the power minus 5t, u prime minus 5 times e to the power minus 5t, u, and 3 times e to the power minus 2t, right? And all right, the left hand side is nothing but the derivative of this, right? When you take the derivative, you exactly get this expression. So e to the power 5t times u is just integral of this. Integral of this is just minus 3 over 2 e to the power minus 2t, right? Plus a constant c1. And then from this we get u equals, if I multiply with this, so minus 3 over 2 e to the power 3t plus c1 times e to the power 5t. Well, we are not looking for u, we are looking for v prime, v, which is just integral of u basically. So I have this. Hence, v is what? Integral of this gadget. So it will be minus 1 over 2. Okay, let me say integral of u dt. So it is just minus 1 over 2 e to the power 3t plus c1 over 5 e to the power 5t. Okay, so plus maybe a second integrating factor, constant. And what was the solution? Now y equals v times u1, right? u1 was not u1, v1 was e to the power t, right? So y is v times y1, which is e to the power minus t. So let's do that. Okay, so e to the power minus t times v, which is minus 1 over 2, 3t plus c1 over 5 e to the power 5t plus c2. So we get what? Minus 1 over 2 e to the power 2t plus c1 over 5 e to the power 4t plus c2 times e to the power minus t. Well, since c1 and c2 are arbitrary constants, I can just write it this way. This is just another arbitrary constant. And you see that this is nothing but our complementary solution, right? Complementary solution. And what is this gadget? This has to be our particular solution. And this method gave us the general solution already, okay? So here C1 and C2 are just real numbers or complex numbers. So this is the general solution. So if you take this constant C1 and C2 to be 0, while we are doing the computation, you would get only particular solution. But if you just keep them, at the end you get not just the particular solution, but the general solution, including the complementary part. All right. Now let me stop here for break. In the second hour, we will continue.